Good morning. Today I will talk to you about a project I did in 2020 on a Coptic manuscript with papyrus leaves. Our goal was to find out more about the materiality of the codex and the way the binding is constructed. The second goal was to stabilize the object for further use in exhibitions. The codex is a special object in the collection of the Dutch National Museum of Antiquities in Leiden. It is one of the few codices in the collection. But also in terms of book history in general, it is a very rare example of a complete Coptic codex of this age. You are looking now at a 3D model I'm scanned in the museum, and you can also find this 3D model uploaded on the website of Sketchfab. If you search on AMS9, you find it. There's a lot to say about the codex, but today I will highlight 4 aspects. First, I will give a short introduction to the life of the codex in the museum and a more technical introduction of the codex. Then we will look more closely at the binding structure of the codex, and from there on we dive on into the papyrus book block. At last, I will tell you more about the conservation treatment I performed. The Dutch National Museum of Antiquities in Leiden, the Netherlands, has a world-famous collection of Egyptian artifacts. The origins of the museum, which was founded in 1818, lie in the collection of the Leiden University. In 1828, the Dutch government, on the advice of Caspar Reuvens, the first director of the museum, bought a large collection of Egyptian artifacts from Giovanni Anastasie. He's back. Now known as the Anastasie collection. Anastasie was a Greek merchant based in Alexandria, Egypt, and he served as a consul for some time and carried on an extensive trade in antiquities. The British Museum bought a large collection from him in 1839 and 1857. When the objects purchased from Anastasie arrived in the museum on the 1st of January in 1829, an inventory book was made for this acquisition. Under the heading Manuscripts sur papyrus et autres, manuscripts on papyrus and others, we find 2 papyrus books, numbers 9 and 66. AMS 66 no longer has the form of a book. It consists of loose papyrus leaves, which are now kept between glass sheets. Hardly any visible traces of a binding are left. AMS 9 is thought to originate from the city of Thebes, modern Luxor. The written text is in the Coptic language, which uses the Greek alphabet with some additional letters. The 30 pages comprise 9 different texts. The codex can be classified as a handbook. It contains a series of texts that may be copied to make powerful amulets. Some of the texts are magical writings, some are of a more ritual nature. The book also includes a few prayers by St. Gregorius and a pair of texts by Abgar and Jesus, which were not included in a canonical Christian Bible. The text presents a worldview that's entirely Christian. It was most probably produced by a monastic copyist. The codex dates from between the 6th and 8th century Egypt, the final century of a period commonly designated as late antiquity. The dating was recently set by Corsidoso, his research, who will publish this year a new translation on the text of the codex. The manuscript consists of 3 gatherings of papyrus bifolios, sewn along with boards made of papyrus scraps and the leather covering, decorated with laced parchment strips. The codex is complete, by which we mean that all elements of the physical book are there: the text block, the sewing thread, the boards, remnants of M-bands, and the leather covering. AMS 9 is one of the very few Coptic manuscripts still housed with its cover. The codex measures roughly 22 by 14.5 centimeters, and the boards are not exactly square. The edges of the boards are slightly broader on the tail side. The boards have a thickness of approximately 1.5 centimeters, and the thick boards are incredibly lightweight. They consist of papyrus, and based on what we can see, they are made by filling a folded sheet of papyrus with crumbled papyrus fragments and bits of other plant materials, such as twigs. The leather covering is a patchwork which must have been pieced together before the white stripes of skin, probably parchment, used for the decoration, were laced through. The textblock was sewn with a link stitch sewing over 3 stations, and the last gathering was sewn first. The positions of the sewing stations are fairly evenly spaced out, but not exact. The textblock is consisting of 3 gatherings only. The bifolios are not evenly distributed over the gatherings. The first has 3 bifolios, the second has 4 bifolios, and the last consists of 1 bifolio only, of which the last leaf is pasted onto the inside of the board. Parchment guards on the inside of the gatherings were used to prevent damage to the papyrus bifolios while sewing. These strips are fragments of waste parchment folded with the flesh side outwards, and they are slightly shorter than full length. There is evidence that the codex had end bands. They are now lost, but a few threads remain and are visible in the inner joints, where they protrude from under the boards and the covering leather. In addition, sewing stations can be detected in the papyrus that would have been used for tie-downs, close to the head and tail of the gatherings. These traces point to traditional Coptic endbands made with a thick thread attached to the head or tail side of one of the board first, 1.5 centimeters out of the board edge, then crossing the gatherings while forming tie-downs and fastened to the other board. At some time in the 19th century, the codex was subjected to a repair campaign. We do not know the precise date of this intervention. It must have been before 1897, judging from the oldest photograph of the codex known to us, which shows the repairs. Today, the state of the object seems more or less the same as in that photograph, except for some changes. For example, in the middle of the back cover, in the circle decoration, holes are now visible. These have been caused by a bookworm larva eating its way through the book sometime in the last 100 years. Traces of damage caused by the worm can be also seen on some of the papyrus leaves as well. At the moment of the repair campaign, there was a split in the text block between gathering 2 and 3. Therefore, the codex can be opened easily in this place and it will lie flat. The text block spine and the spine on the inside of the leather covering are completely pasted over with a lot of adhesive, probably a gum and a transparent paper, the so-called papier végétal, in the inventory books. Another repair material used on the codex can be found on the cover. In quite a few places on the front and the back cover, a black putty substance has been used to fill gaps in the leather covering and missing pieces on the boards. We used different solvents to see if the black putty could be dissolved in anything, but this was not the case. As we can see later on the X-ray photograph, the repairs on the cover are very white on their X-rays, and it is very likely that the repair material contains lead white, which does not let X-rays through. A search in the museum ledgers led us to find that all materials needed to make stopverf, a putty or a mastic, were present in the inventory. Putty was used in the museum for repairs on the cabinets in the museum rooms. Ingredients are lead white, oil and turpentine, and some zwartsel, a black pigment. Lead white and oil will form an insoluble chemical reaction over time, becoming a hard and insoluble substance. It is very likely that putty was used for the repair of the cover. Though this repair material has not caused much problems on the cover, it has also been used on the outer joints. In this flexing area, there are large cracks in the rigid putty. Not being able to remove the putty in these areas, we have smoothed the edges of the broken parts to make the flexing of the joint somewhat easier and less harmful. It is extremely fortunate that whoever was in charge of making the treatment decision decided that this codex did not require dismantling, as so often was the fate of Coptic codices upon arrival in Western institutions. As a result, the text block retained its original structure. Although the codex has been repaired and new materials have been added, all original material is still in place, and it is still possible to study the manuscript's components and the method used to bind it. We will move on to the next part, from thread to binding. The initial investigation of the sewing of the text block did not clarify how the sewing thread was attached to the covers. We therefore decided to make X-ray photographs of the two covers, hoping to find out more about the ends of the sewing thread. Low radiation was sufficient to produce very good results. The result was surprisingly because our eye fell in first onto a large repair in the cover. The photograph shows two large pins in the lower corner of the front cover. Though we had noted the repair of this corner, a layer of thick white paper covered the material underneath. The X-ray photograph made it clear that the entire corner is a new addition to the cover, secured with two long pins. The outer sides of the pins are somewhat fuzzy on the X-ray. This suggests that the pins are made of metal and are corroding. This was subsequently confirmed by using a magnet. After removing all the repairs on the spine during conservation, the binding structure much more revealed. The binding has three stations, shown by the blue arrows. The red arrow indicates the thickness of the boards and of the last section, which is a bifolio, and the purple arrow indicates the piece of the sewing thread, here visible because part of the fold has teared. The X-ray photographs makes visible the passing of the sewing thread between the holes in the boards and the number of threads passing between the holes and the joint. The simple structure explains how the visible loops extending from the outside of the boards were formed, and based on this information, the board attachment was reconstructed. With all this information, we come to the following reconstruction drawing of the sewing thread. In this case, it was not fastened the manner that is usually described. The evidence shows no bridles or loops around the board edges. Instead, there are simple loops that exit from one side, the exterior, of the board. The location of these loops corresponds with the sewing stations and the holes in the boards where the thread is laced through. At which side the thread was attached first is not directly visible, but judging by the passages of the threads, it seems the bookbinder started at the tail and then worked its way to the other side. This method, to our knowledge, has not been reported at all, nor has it been reproduced in drawings or reconstructions. It appears to be a quick and secure method, unsteady as it may seem in theory. Let's move to the third part, from roll to book block. It has been accepted in the literature in general that the material for the fabrication of papyrus codices was taken from papyrus rolls. The roll was the standard form in which papyrus was sold, and thus the natural procedure was to fashion leaves by cutting off sheets of the appropriate size from a manufactured roll. Generally, the rectus side of the roll is the side with the strips of papyrus running parallel to the long edge of the roll. In the case of this codex, form the individual strips within a sheet of papyrus a pattern and can be recognized in the codex. In addition, the different shades of brown help to distinguish the individual strips of papyrus. The codex opens with a vertically oriented page. The second bifolio is oriented counter to the first. The third bifolio is oriented vertically again, like the first bifolio, and the rest of the bifolios in gathering 2 and 3 all have the same orientation as the second bifolio of the first gathering. Knowing that the folios were most likely cut from a roll, we tried to find clues for this practice, in Amos 9 as well. While removing old repairs from the spine during the conservation treatment, the second gathering came loose from the rest of the book text block. This allowed us to place the double leaves next to each other to look for fiber continuation and to ascertain if and how the sheets were cut from the roll. For placing the rest of the double leaves and puzzling, we used Photoshop. We managed to match 2 sheets from gathering 1. The bottom side of bifolio 2 matches the top side of bifolio 3. It was not possible to physically examine the first gathering in a similar way. Instead, we photographed all sides with the vertical orientation of the papyrus fibers to try and match the folios digitally, and we were able to successfully relate bifolio 1.2 and 1.3. Also from gathering 2, we were able to match 2 bifolios, 2.2 and 2.3. And let's move on to the last part, the conservation. The conservation of the codex mostly existed out of removing old repair materials which was added so abundantly. Transparent paper was added on all pages along sides as well as the spine, and the transparent paper was relatively easy to remove by moistening with methyl cellulose and the aid of a spatula. The old repairs of the textblock leaves were of course applied with a reason, so removing them necessitated new repairs. Loose bits, small cracks and delaminating papyrus were secured by use of a 12 grams Japanese koso paper and the adhesive MC, methyl cellulose, in different percentages. Small strips of Japanese paper were added along almost all sides of the leaves to secure damaged areas and to prevent further damage to the papyrus while handling the page. As the ink was friable and flaky in some areas, it was decided to consolidate the ink with a diluted solution of phenori in water. This was applied with the ultrasonic mister, which turned the solution into a condensed mist, allowing tiny droplets of adhesive to be applied to the surface of the papyrus. The solution was thus applied evenly over the surface and in consecutive sessions, as to prevent the application of too much water at once. The split in the joint in the leather has been strengthened with toned Japanese paper strips, first to follow the irregular shape of the split. The Japanese paper strips could be placed between the textile spine covering and the leather. A single piece of Japanese paper closes the split in the leather. Of course, I was only to tell you in this time frame a few subjects of this codex, related to this codex, and there's so much more to tell. You can read more of our research in an article which is in its final stages of editing and will be printed later this year in a series of Swathe Mechanicals, edited by Julia Miller. And I would like to thank my co-author, Karin Scheper, especially for her enthusiasm and her work on this project, and of course all the other people on this slide. Thank you.
Thank you. Comments, questions from the public? There's one over there. Two.
Hi, Beatriz Torres from Linz. I would like to know more about the X-ray. You mentioned you did it by yourself, so there's also a photo, and I saw you are developing too. Can you explain a little bit if this is a current practice you do in the museum?
Yeah, no, we hire someone to do it. I cannot do it myself. So it's René Gerritsen, and he has the X-ray tube, you call it. And he develops immediately because you need to see if there's enough radiation to go through the material you like. So that's why we develop immediately and then take another photograph with more longer time of exposure. Or yeah.
It was another one, the one in the back.
Jerzy Vnuček, Royal Library Copenhagen. Thank you for a very interesting talk. I only have a question about the covering, the leather. Have you analyzed what type of the animal it was, or how was processed the leather?
No, because we didn't want to do any destructive analysis for now. We are very hesitant about that. And there's hardly any hair implant visible on the leather. I only could find a small piece where I could still find a few hair implants. So it looks like sheep or goat. It's very hard to tell, yeah.
Thank you. Any more questions or comments? just a quick one. How long did it take you to do the whole conservation treatment? It seems very complex.
Yeah, the conservation was actually the least complex of this whole thing, because it was quite easy to remove all the old repairs. They came off very easily, so I guess a week or so, yeah.